Okay, hello Lawrence. Welcome to our podcast. Thank you very much for accepting our invitation, and it has been a pleasure for me to have you here. First of all, I would like to ask you if it is possible for you to briefly introduce yourself and provide us with some information about your experience and background in the field of laboratory accreditation.
Well, thank you very much, Hamid Reza. It's certainly a pleasure to be with you. Unfortunately, only here remotely. Looking forward to come back to Tehran someday in the future again. It has been a pleasure always to be there. Yeah, I mean, thank you for inviting me again. And I have been dealing with these issues of quality assurance, quality management in laboratories for almost 30 years, about 30 years. And especially also accreditation of laboratories. I used to be a quality manager of an accredited laboratory and have built up quite some experience in that field, also including the many issues related to that. For instance, method validation, measurement uncertainty, and quality control, and so on. And that has become my kind of field of experience and expertise, and that's why I do these kind of trainings, consultancy, whatever, around the world on issues related to quality management, quality assurance in laboratories, and especially talking about method validation. I have for many years been joining the European organization EuroChem. Hopefully you're aware of that one. And I'm actually chairing a special working group within EuroChem where we are dealing with method validation, and you may be aware of the guide issued by EuroChem on fitness for purpose for analytical methods, where we are giving advices on how to perform method validation. And that's my background for also dealing with the subject today.
Okay, thank you very much for the introduction. My first question is what are the differences between two terms which are used in ISO 17025, method validation and method verification? How should we differentiate between these two terms?
Yeah, well, that's a typical question here, and it comes up every time I do any kind of training on this subject. And it is actually a little bit confusing because when you look into some formal definitions of the word validation, it starts talking about validation is a verification, and then it goes on. I cannot remember the exact wording. Just to make it brief here, to verify something is to secure that something is in accordance with specifications, and to validate something is to be sure that something is fit for the purpose, as we call it in EuroChem, that it's fulfilling the intended expectations of the use of whatever it is, in this case an analytical method. So when we do the validation, we are securing that the method we are applying for a certain task, for a certain purpose, is fulfilling all the requirements which are stated by the client in this case for that method. Whether it goes towards, it has to be able to measure to low levels, then we are validating if the limit of detection of that method is okay. The client expect the method to be able to measure from low levels to high levels, then we are keen on validating the whole range of the method and so on. And based on that, and that should be the first thing done with a new method, a new developed method, that it can fulfill whatever is expected, required from those asking laboratories to use that method for a specific purpose. Based on that, the method comes up now with some specification. It can measure from that level to that level. It has a precision of so and so. The bias issues are of limited importance in that method, and so on, whatever could be important. That should be specified in the method, a validated method. And then you have specification against which you can verify. So that's why we talk about method validation to be the basic thing which should be done for all new methods, securing that can be used for various purposes. Then if the laboratory takes up an already validated method, typically called a standard method, well, they have to verify that in their laboratory, applying the method in their laboratory, those specifications can be fulfilled. But in this case, we know that the method is expected to measure from there to there. So we have to verify. We can also achieve that when we apply that method in our laboratory. We are verifying against those specifications. So the method validation is, to me, the basic things to be done on every new method or modified method, whereas the verification, well, we are just confirming that in our laboratory, we can also achieve that when we are applying that method.
Okay, in order to conclude that, you mean that when an institute, a standardization institute publishes a method, they do the validation part, and my job in my lab is to verify my capabilities to perform the method correctly in my laboratory. Am I right?
Exactly. And then as we will probably come to that a little bit later, but we know also that the 7025 for the accredited laboratories are keen on saying, well, if you modify anything in the method, I mean, if you change the originally validated method, of course, then it's not valid anymore, because it's not the method which was validated in the beginning. You have changed it, you have modified it.
Mm-hmm.
And then, of course, the laboratory have to do some kind of additional validation to secure that these modifications are still fulfilling the requirements for the method.
Mm-hmm. Okay, my next question is exactly the point that you just mentioned. In ISO 17025 standard, validation is only necessary for non-standard methods, in-house methods developed by the laboratory, or some sort of modified methods. But in some areas, such as food testing with high sensitivity, typically assessors ask for food validation when they come to laboratories. Even for the standard methods, they require all performance characteristics to be analyzed in the laboratory. Do you agree with this? And what would be your comments about this?
Well, yeah, I mean, as I foresaw, we are actually coming back to what I mentioned before, this issue of non-standard methods versus standard methods and modified methods. And yeah, I mean, 7025 is mentioning something about this. The interesting thing is actually when you see the new version of 7025, the 2017 version, compared to the previous version, 2005 version. The new version starts out with talking about verifying methods, and then secondly, further down in the paragraph, comes to validating methods. It was exactly the opposite in the old version, but it started talking about validation a lot. But I mean, it takes for as a basis that most laboratory will, in their routine testing work, make use of standard methods which are already validated and which they then should only verify for their application in the laboratory. Then there are all these things in between of modified methods and so on, and of course, I mean, as soon as the original method, which was validated by those who are issuing the method or developing the method, if this is changed, well, then it's not a valid method anymore, and you have to secure that it's a valid method with the new modifications. So you must do something about that. This issue of full validation for standard methods, I had never come across that before. Is that typically in Iran? I don't know. Normally, you shouldn't do a full validation when it is already a standard method, and you can prove that and that's a precondition to only do verifications, that you follow that validated method to the letter. Don't change anything. But if you do that, follow it to the letter, I don't see cannot see it's fair to ask for full validation, because it is already validated. Sometimes in older standard methods, it can be difficult to find out what was the outcome of the validation. What are the specifications for this standard method? So you have nothing to verify against, because it's not specified in method. What what are the characteristics of this method? What is the limit of detection, for instance?
Mm-hmm.
Is that mentioned specifically in the validated standard method? In old methods, not always. So you don't know what to verify against. And in that case, of course, you can have to do a more detailed work on validating some of these parameters, because I mean you have to document yourself what is, for instance, the limit of detection of such a method. But otherwise, if it's a method which is validated, you can find the documentation for the validated method. I don't find it fair to ask for full validation.
Okay, thank you very much. My next question is let's go to the term standard methods. What methods are considered as standard methods? And based on your responses, validation is not necessary for them. Can we say that some different accreditation bodies have different policies in recognizing a method as standard methods? Some say that a method which has been published by a reputable equipment manufacturer is considered as a standard method, or some industrial associations I have encountered with, for example, in methanol testing, there is an international association called IMPCA, International Methanol Producers and Consumers Association. They publish some standard methods for testing on methanols. Can we consider these kind of methods as standard methods, or no, we should be limited to standard organizations, national standard organizations, that their methods should be considered as standard methods?
Well, to answer your very last question directly, no. I mean, I think that we also have to consider methods issued by well-known, recognized kind of sector organizations within, for instance, in methanol testing or in the food testing, or I mean, especially in the oil testing, you find a lot of these very, very specific methods for that. And well, there's no definition of a standard method, neither of a standard organization, so to say. I mean, what is that? This has been an old debate. I remember we discussed that, well, more than 20 years ago. What is actually a standard method? I recall that the Swedish accreditation body at some point had a list in their kind of guidelines for the accredited laboratories, a list of what they would recognize as standard organizations. I think they have left that many years ago, but I mean, it is a question still, and certainly, I mean, if you go into the literature, you will find thousands and thousands of methods published in nice magazines, scientific journals, and so on, printed on nice paper and whatever. But be careful. I mean, often these methods which are praised of, oh, look what we can do with our method, have not been properly validated. So that's why you have to be critical. I mean, not whether it's called a standard method or not, but whether you can see some documentation for the validation behind the method. And I mean, I would think of some of these sector organizations, like, for instance, the methanol testing organization and whatever, that they have been keen on saying, well, for our purpose, in our group of laboratories or enterprises dealing with methanol testing, we want to have a method we can handle within our kind of group. And they have probably stated established a method and validated that method for that purpose, and that would be fine to me. I mean, and again, you will probably be able to find the documentation behind that validation, and well, then you know it's a validated method. Whether it's called a standard method or not, it's not so important. It's not the word standard here which is the important thing. It's the word validated.
Mm-hmm. What you mean that first the laboratories should follow their national accreditation body policies in regards of recognizing a method or association as a standard method, and secondly, they should look for performance data published by the method itself, and to see how far the validation has been done. Am I right?
Yeah, I mean, I think many accreditation bodies will not have a clear view of that either, because it's very debatable. I mentioned that old example from the Swedish accreditation, but I don't think they have that list anymore, and I don't think you can find that kind of list with any accreditation body nowadays. So I mean, it's in many cases, especially now based on the new version where we talk about risk assessment in relation to how much you do for your quality management and quality assurance. I mean, it's up to the laboratory to be able to prove and justify, we have done this and this and we have used this method because it looks like a validated method. That's why we have only verified it and so on. So it's the responsibility of the laboratory to document that, well, eventually the method applied is valid for the purpose.
Okay. My next question is that in ISO 17025 standard, there is no requirement for revalidation of a method. Could you please tell us your idea about this and let us know when revalidation is required in practice for the laboratories?
It's a very good question. Also, we are actually touching a little bit on that in the Fitness for Purpose guys, the Eurochem guide, and surely, I mean, and that's where the current monitoring of the performance of the method comes in, whether it's via or by help of internal quality control measures, setting up a system there, which I think all laboratories should do. Be keen on also not only if it's a complex method, you may even have several points where you do some kind of control, not only on the final results. For other methods, you can just have some regular control materials you are testing on a regular basis and follow the development of the method. But not least, participating in external quality control in proficiency testing schemes or interlaboratory comparisons is a very, very important tool here. And especially if you do that on a regular basis over time with a reasonable frequency, so you can see any kind of trends in how your method is performing in your laboratory. And certainly, both for the case of internal control and external control, if your method starts giving strange results, whether it's too low, too high, or very changing results or whatever, it's time for going back to see, well, what is wrong with our method, and do some kind of revalidation or whatever you call it. And that's also where having your internal control with a rather good frequency can be very helpful to see when did this start, and can we find some points where it seems that the method is not working perfectly anymore, and that's where you should go in and see if you can well, improve your method to be fully valid again.
Can we say that having a comprehensive and well-organized quality control in the laboratory can assure us that we continuously monitor the performance of our method and different characteristics of our performance, and all the changes that happen in the laboratory over time can be monitored, and we can be sure that our method is still in a validated situation by applying this comprehensive internal or external quality control plan? I
think so. I think that's absolutely crucial here, that you set up, as you say, it must be planned. It must just be some kind of haphazard, not doing it now and then when you feel for it. No, it should be really into a plan, that it's run according to some kind of schedule and with a reasonable frequency. And of course, it must also be arranged, the internal control, that it is kind of mirroring what you're doing routinely with your real samples. And the same goes, of course, for the external control participating in ILCs, proficiency testing. They must be relevant for the routine testing you're doing. They must picture what is the performance of your method when you use it routinely. So it should be relevant and appropriate kind of control scheme. Okay. My next question, that in most of the reference literature, including a Eurochem Fit for Purpose guide, there are several performance characteristics for chemical analysis.
and these performance characteristics are evaluated during method validation. But for other areas of testing, such as mechanical testing, our choices for performance characteristics are only limited to precision and bias. Does it mean that checking precision and bias would be sufficient for method validation in areas such as mechanical testing?
That's a very good question. I actually occasionally have been dealing with non-chemical laboratories. I was invited to do something on setting up a quality management system for electrical testing laboratories some years ago, and it was a totally new world for me. And of course, I mean, they don't talk about some of the characteristics, for instance, like limit of detection and things like that, depending on what kind of test we're talking about. So yeah, I mean, again, that actually goes a little bit along with some work we are doing in Eurochem now in our method validation working group, where we are working on a new supplement to our guide on the extent of studies to be done in laboratory to document the validity of a method. And that goes both on which performance characteristics are important and how much should be done, how many tests should be done in the laboratory over how long a period. And we actually recommend, it's certainly a very early draft right now. We're going to recommend that also for the number of performance characteristics, even for the chemical methods, not all of them are always important. I mean, the limit of detection, that's a typical example to mention. If you're only measuring on high levels, you don't care about limit of detection. One of the common characteristic which is left out is sensitivity. I mean, if that's not important to you, you don't do a lot about that. So even for the chemical testings, you are leaving out things which are not relevant for that exact performance or application of the method. And I mean, I could take that to the mechanical testing, of course. I mean, if you're not talk about limit of detection or sensitivity, or if your method is not going to be transferred to other laboratories, the robustness, which is one of the characteristics, is not relevant. So you can leave it out, and I mean, the same for the mechanical testings, of course.
Okay. My next question is about the method validation for qualitative analysis, such as microbiology identification or similar methods. I know that you have been working on this issue a lot, and it takes some time, but could you please briefly tell us how method validation should be done for this kind of testing?
Oh, another big question. Yeah, actually, in the present version of the methods of the fitness for purpose guide, we are only touching very briefly on the issue of qualitative analysis, and it's in the context of limit of detection. And of course, when we are talking about qualitative testing, the limit of detection, when can we say that is something compared to that is nothing, is crucial. Whereas certainly the measuring range and precision and things like that are not immediately relevant. Going a little bit into this issue of qualitative testing, where we talk about is there something, is there nothing, we are very keen on looking into these false negative, false positive situations, the risk of making the wrong decision, whether there is something when there was something, and vice versa. And that will be the key point in this approach on qualitative analysis. We are actually on the doorstep to do something about that in our method validation working group in Eurochem, because we have started a cooperation with another working group within Eurochem, which is actually dealing with qualitative analysis, and is just on the doorstep to issue a guide on measurement uncertainty in qualitative analysis. And how can we talk about measurement uncertainty in qualitative analysis? Yeah. I mean, there is some concepts based on these considerations of the likelihood of false positives compared to likelihood of false negatives, and more semi-quantitative measures like that. So I mean, it's certainly not a field where I'm the expert, but we are now seeking expertise in the other working group and trying to do something in common on that subject. Talk about microbiology. I mean, there is a lot of quantitative analysis in microbiology also, because when we are trying to come up with the numbers for what's called the colony-forming units for how many microorganisms are there in certain samples, and we know that's a difficult quantitative measure, but that's the best we can do in microbiology, and certainly in that field something can be done and is done. There are also ISO standards in the field on how to deal with that. We are actually also right now discussing in our working group whether we should do a little annex in the next version of our fitness for purpose guide, dealing with the specific issues related to microbiology compared to what we are normally talking about in analytical chemistry. So that's probably how much I can say about this right now. It's an important issue, especially in microbiology, but also some of the new biotechnology methods are, well, we sometimes call them semi-quantitative, and it becomes increasingly important to do something about this.
Thank you. My last question is that in some sectors like food analysis, a single method might be applied for different types of matrices and different types of analytes. For example, analyzing pesticide residue in food. And performing full validation, which covers all of the analytes and typical matrices that a laboratory might encounter, is not practically possible for a single laboratory. How they should proceed with validation in such a case?
Yeah, I mean, if I understand it correctly, you are referring to these what we call multi-parameter methods.
Multi-parameter and multi-matrix methods.
Yeah, okay. Multi-matrices. I mean, I would actually distinguish a little bit between these, but let me take the multi-parameter first and say, well, of course, pesticides is an obvious example in fruits and vegetables, and we know there are, I don't know how many hundreds pesticides to look out for nowadays, and the typical advice there is to look into groups of parameters, pesticides in this case, which are chemically acting or analytical chemically acting similarly. So to take a representative for one of each of these groups, you know that the chemical composition of these pesticides is very different from group to group. And that's why we also expect them to behave differently in the analytical process. For instance, for the extraction, the chromatographic process, and so on, they will behave differently. And that's why we should have a representative for each of these groups validated. Not every single of them, but if we can say, well, this one pesticide we have validated, and that's why we also believe that our methods will be okay for the rest of pesticides within that group. So that would limit the effort considerably, but still there are a lot of things to look into, and certainly pesticide analysis is a challenge. We see a little bit the same in some of the drug residues analysis and things like that. But again, I would recommend the same approach. When we talk about multi-matrices, yeah. Again, if a matrix is I mean, it's not only the question of pears and apples and oranges. It's also having the experience, knowledge about the analytical chemistry behind the method. How is this method actually working? And one typical example is if we are looking for a analysis in a certain type of matrix, we know that the analytes we're looking for are water dissolvable, whereas in other matrices they are mostly what's called oil soluble or in some kind of organic solvents. So these kind of chemical behavior in the matrix is important to look into. So again, I mean, and that's typical for many validation studies. I mean, it's not just following a general protocol. It's also using your chemical knowledge of chemical composition, of chemical analytical behavior, of solution behavior in different types of solvents, and of kind of chemical reaction behavior for different types of chemical compositions. Having said that, also one important issue is, of course, the whole issue of I forgot the word now. Tell me the interactions, the interferences. Sorry, the interferences between the compositions in the constituents of a certain composition of whatever kind of sample you're looking for, whatever kind of matrix you're looking for. Looking for some analytes, you know that there are a lot of other materials in that matrix which may interfere with your analyte. And that's again something to look into when you look to different matrices. What could be the possible interfering compound in that matrix compared to the one we are already dealing with? So things like that you have to look into and make a proper analysis of this, theoretically what could be the problem here, and pursue that if you see a problem. If you don't see a problem, you must be able to justify why you don't see a problem.
Based on regarding the different matrices, sometimes a certain method, in the scope of the method, it says that it can be applied for all petroleum products. We have it in our petroleum industry and petrochemical industry in Iran, that they use a method for measurement of flash point in petroleum products. But I have noticed that some accreditation bodies are not very easygoing, that they come and say that, okay, if you have method validation only for gasoline and naphtha, and you have not extended the scope of your activities during method validation for other matrices, in your scope of accreditation, we exactly say that only for gasoline and naphtha, not for the whole scope of the method, because you have not checked if you have not verified your performance for other types of matrices based on what you said, that there might be some, for chemical analysis, there might be some interferences, or the range would be different for other petroleum products, and they are not good at that range.
Yeah, exactly. I mean, I think that illustrates very well the problem I said of interference problems, because I mean, we know the presence of certain heavy metals and things like that may interact with the chemical process and give a skewed picture. So you must be very aware of what kind of other interfering compounds could be in the other types of matrices.
Okay, thank you very much, Lawrence. It's always a pleasure for me talking to you. It's learning opportunity for me, and I'm sure that for all of our audience and listeners, it will help them to increase their awareness. Thank you very much for the time, and thank you very much to be here.
It was my pleasure indeed. Hope to go back and see you all again someday in Tehran. Okay.
Okay, hope to see you again. Thank you very much.
Okay, thank you.
Thank you.